In this code, how many buses that we can use to reach the end of the code? So we can go in the path yes and yes, yes and no, no and yes, no and no. So these are 4 paths. So here we will use 4 test cases, okay? The 4 test cases will cover the 4 paths that we can use. So let's use Python and execute it. Let's run. The first test case, we need C to be greater than 100 and A to be greater than 50. So we can say 60 and 50. Here it's done, it's pending. The second test case, C is greater than 100, but A is not greater than 50. So A, for example, is 20 and B is 100. So here he printed it's done only because he went in print it's done, but he didn't go to print it's pending. The third test case is we want C to be not greater than 100 and A greater than 50. So A is 60 and B is 10. Here he printed it's pending only. The last test case, we don't want him to enter any print statement. So we say A is 20 and B is 10. Here he skipped the 2 if statements. In this example, define foo, which is a function x and y, for I in range of x. What does this mean? So x, for example, is 3. So I will be 0 and we do this something, and then I will be 1 and we do this something again, and then I will be 2 and do this thing 3rd time. So we will go in this loop 3 times. If y something else. So how many test cases are required to achieve 100% pass coverage? Here we can't answer this question. Why? Because x can be any number. What if x is 10? What if x is 11? What if x is 1000, 2000, 10,000, any number? So we have infinite number of values for x. So here we can't achieve 100% pass coverage. This is impossible, okay? This is what we call exhaustive testing. We cannot test everything. So most of the time, pass coverage is not achievable, okay? The example that we did pass coverage on was very simple. And in real world, we don't have code like this. The code is more complex than this. So pass coverage, we use it, yes, but not to achieve 100% pass coverage. We can have a goal in our plan to achieve 100% statement or decision coverage. But for pass coverage, no, this is impossible.